We are tracking a number right now that is, frankly, difficult to wrap your head around. If you put it into context, it is bigger than the gross domestic product of most countries on Earth. And the craziest part about this number? It is basically just a massive waiting list.
Exactly. Welcome back to the Working Thesis. Today, we are kicking off a brand new series we're calling the AI Power Problem. Over the past few years, the entire world has been talking about chips, about GPUs, and about parameter counts. But the real story of the 2020s isn't going to be about the silicon itself. It's going to be about the infrastructure required to actually plug it all in.
As of mid-2026, the technology sector has promised on the order of $2 trillion in contracted cloud backlog, a big chunk of which is directly driven by AI. But signing a contract is the easy part. Actually delivering that compute means navigating supply chains, real estate, and ultimately a hard physical limit.
Right. You can buy the hardware, you can stack the servers in a warehouse, but if you don't have the power to turn them on, you just have a very expensive, very quiet room. So today, we follow the money. We are starting with that $2 trillion figure to understand exactly where it comes from and what it means for the physical world. First, a quick and honest word. Everything you're about to hear is really just the two of us thinking out loud. Personal market commentary, made for learning and for fun. It isn't investment advice, and it isn't a recommendation.
And when we talk about a specific company, it's only ever to make a bigger idea click. Never a nudge to buy or to sell. So take it as a starting point for your own curiosity. Do your own research and make the call that's right for you. To understand the scale of what is happening right now, we have to look past the usual headlines. We aren't looking at quarterly revenue or stock prices. We are looking at a specific accounting metric called RPO, which stands for Remaining Performance Obligations.
RPO is essentially contracted but undelivered revenue. When a company signs a massive multi-year deal to rent cloud servers or AI compute, that money doesn't hit the revenue line immediately. Instead, it goes into the backlog. It's the clearest gauge of committed, legally binding demand that we have.
And when you add up the RPO across the major players in the cloud and AI space as of mid-2026, you arrive at that staggering tally, roughly $2 trillion. It is the closest thing to a crystal ball for the industry, showing us exactly how much infrastructure the world has pre-ordered.
But reading that crystal ball requires a bit of nuance. The numbers are massive, but they're also deeply concentrated among a few key players who are fundamentally reshaping how capital is deployed in the tech sector. Let's break down exactly who is holding these promises.
Let's start with the traditional giants, the hyperscalers. Microsoft is sitting on roughly $627 billion in RPO. Google Cloud is holding around $462 billion, and Amazon's AWS is looking at about $364 billion. Just between those three, you are well past the $1 trillion mark.
It is a breathtaking amount of capital commitment. But there is an incredibly important caveat we have to state right here on camera. This is not an apples-to-apples comparison, and it is not all AI. Microsoft's $627 billion, for example, spans all of its commercial cloud offerings, not just its artificial intelligence products.
Exactly. So when we say there is on the order of $2 trillion in contracted cloud backlog, we have to remember that a big chunk of it, but not all of it, is AI. Standard cloud migration, enterprise software, and legacy database hosting are all mixed in there.
Still, the acceleration in these numbers over the last few years is undeniable. And the primary catalyst for that acceleration is the scramble for AI compute. Companies are locking in capacity now because they are terrified of being left behind if a compute shortage materializes.
While the big three are putting up massive absolute numbers, the most fascinating story in the RPO data belongs to Oracle. As of mid-2026, Oracle's RPO has swelled to an astonishing $638 billion. That is a 363% increase, putting them right at the top of the leaderboard.
Oracle's pivot has been nothing short of aggressive. They realized early on that the market didn't just want software. It needed raw, unadulterated power to train and run massive models. They leaned heavily into securing real estate and grid connections to build out specialized AI data centers.
And the market responded by handing them contracts faster than they could physically build the infrastructure. That 363% growth rate is the loudest signal in the market that the appetite for dedicated, high-performance compute environments is structurally changing the cloud hierarchy.
It proves that in the AI era, incumbency isn't everything. If you can prove to a customer that you have the infrastructure, the cooling, and the power to run tens of thousands of GPUs in a single cluster, they will sign the dotted line, regardless of who they used for legacy cloud hosting.
The demand is so overwhelming that it has actually birthed an entirely new category of companies, the neo-clouds. These are specialized providers built from the ground up specifically for AI workloads, bypassing the legacy architecture of the traditional hyperscalers.
CoreWeave is the poster child for this movement. They're sitting on roughly $99 billion in contracted backlog. Then you have Navius, holding around $50 billion. These are companies that, just a few years ago, were barely blips on the enterprise radar.
And now they are holding tens of billions of dollars in promises. The neoclouds succeeded by being nimble. They bought GPUs aggressively, found secondary markets with available power, and offered a streamlined, AI-native experience that the massive incumbents struggled to deploy quickly.
It is a classic innovator's dilemma playing out in concrete and copper. The sheer volume of demand means the hyperscalers simply cannot absorb it all. The spillover alone is enough to mint entirely new infrastructure giants, provided they can actually deliver on those contracts.
This brings us to the two honest readings of this $2 trillion backlog. Let's start with the optimists. The bull case looks at this RPO mountain and says, demand is real and contracted. This is not a bubble. This is a structural shift in human computing.
For the bulls, an RPO is not a hypothetical projection on a whiteboard. It is a legally binding commitment from Fortune 500 companies and well-funded startups. It means the revenue is already spoken for, de-risking the massive capital expenditures required to build these data centers.
They argue that the transition to AI is similar to the transition to mobile or the original migration to the cloud. You have to lay the tracks before the train can run. The backlog proves that the global economy has universally decided that the tracks must be laid.
In this view, the temporary bottlenecks in hardware or power are just growing pains in a multi-decade supercycle. The contracts provide the financial gravity necessary to pull all the physical resources into alignment over time.
But there is another way to read the data, and it is a lot more cautious. The bear case points out that much of this $2 trillion promise leans heavily on a very small number of aggressively cash-burning AI labs, primarily OpenAI and Anthropic.
This is the circular financing risk. The hyperscalers invest billions into these AI labs. The labs then use those billions to sign massive cloud contracts, RPO, with the very same hyperscalers. It inflates the backlog numbers with capital that originated from the cloud providers themselves.
If those core AI labs hit a wall in model capabilities, or if their consumer and enterprise revenues don't eventually scale to match their compute burn rates, that contracted backlog could start to look very fragile. A contract is only as good as the customer's ability to pay for it when the invoice comes due.
Exactly. It is a concentrated bet on a few apex predators in the AI ecosystem. If they stumble, the ripple effects through the infrastructure supply chain would be massive. The demand might be contracted, but the underlying economics of the end user still need to prove themselves at scale.
Whether you lean bull or bear, there is a mechanical reality to how these contracts work. They are heavily backloaded. We are talking about obligations stretching from 2027 all the way through 2030 and beyond.
Take Oracle, for example. Despite holding that massive $638 billion backlog, analysts estimate they are only converting about 12% of it into actual revenue each year. The rest is waiting on physical infrastructure to be built, energized, and handed over to the client.
This is the core difference between a software boom and an infrastructure build-out. When a software company sells a subscription, the delivery is instant. When you sell a gigawatt of AI compute, you are making a promise to pour concrete, lay fiber, and secure energy that doesn't exist yet.
It means that the $2 trillion tally is exactly that, a promise. It is a lagging indicator of future physical reality. Every single quarter at earnings, these companies have to prove that they are actually chipping away at that mountain, turning paper contracts into spinning servers.
Which brings us to the logistics of making good on those promises. The backlog is fundamentally a map of the future physical world. It tells us where data centers need to be built and how much hardware needs to be shipped.
But as the industry has matured over the last few years, the bottlenecks have shifted. Early on, the race was simply to secure the GPUs. If you could get the chips from NVIDIA, you were winning. Today, the chips are flowing. The silicon supply chain has largely caught up.
The problem now is that the physical world moves a lot slower than the silicon world. You can manufacture and ship 100,000 GPUs in a matter of months. You cannot permit, build, and power a massive data center campus in that same time frame.
The gap between the speed of capital and the speed of concrete is widening. The RPO tells us that the capital has already been deployed. The contracts are signed. The money is waiting. The physical world is desperately trying to catch up.
And within that physical supply chain, there is one choke point that matters more than all the others combined. It isn't the land, though finding good real estate is hard. It isn't the cooling systems, though those are incredibly complex.
It is the electricity. The power required to run the infrastructure dictated by this $2 trillion backlog is staggering. We are moving from an era where compute was constrained by manufacturing yields to an era where compute is constrained by the grid.
Every single one of those contracts relies on the assumption that when the data center is finished, there will be enough electrons flowing through the wire to turn it on. And as we look across the landscape in 2026, that assumption is being heavily stress-tested.
It forces us to ask a very basic, very uncomfortable question. Did the tech industry just sell $2 trillion of compute without checking if the local utility company could actually plug it in?
What is crucial to understand is that this isn't a story of doom or of AI failing. It is a story of an industry maturing. The demand is relocating and broadening. We are seeing a push toward efficiency, toward on-device AI, and toward smaller, highly optimized models.
But the aggregate need for centralized, heavy-duty compute is still growing at an unprecedented rate. The backlog is real. The question isn't whether AI is useful. The question is the speed limit of human infrastructure.
Analysts are closely watching how these RPO conversion rates trend over the next few quarters. If the conversion slows down, it won't be because the customers don't want the compute. It will be because the providers literally cannot secure the power to deliver it on schedule.
That is the tension that will define the next 5 years of the global economy. A digital revolution running headfirst into the physical limits of the 20th century power grid.
So, we have established the stakes. Roughly $2 trillion in contracted promises waiting to be fulfilled. A backlog that proves the demand is there, but also highlights the massive physical undertaking required to meet it.
Signing the contracts was the easy part. Next time on the Working Thesis, we look at the physical wall the industry has hit. We are going to map out exactly how much power this backlog needs, why you can buy GPUs faster than you can energize a building, and what it looks like when a multi-billion-dollar data center is sitting in a field with no wire connected to it.
The chips are ready, the contracts are signed, but as we'll see in episode 2, it's not the chips, it's the power. See you next time.
Okay, that's our episode. The honest goal here is simple. Hold a few ideas about the world and keep checking whether they're still true.
Together, out loud, a little at a time. If you spot where we've got it wrong, please tell us. That's how this gets better. See you next time.